MC over I, right? C is the biggest radius, right? So this is equal to minus MZ over IZZ. Does not matter IZZ or IYY over here, okay, because it's a circle. Multiplied by C, so it's minus 18,000. We found this out. Multiplied by C, divide by pi over 4, C to the power 4. Okay, so this is equal to the second moment of area of a circle. So this is equal to minus 72,000. Right, so this is the easy part, pi c cubed. Okay, so now we know stress X will be equal to minus 2,500. Okay, pi c squared. Right, and then this will be equal to minus 7,200. No, 72,000. Okay, pi c cubed. So we make it as a common denominator, pi c cubed. So we have minus 2,500 c minus by 72,000 divide by pi c cubed. So this is the easy part. Now you all look at it like, yeah, Eugene, this is the easy peasy. Then we're going to look at due to shear. Okay, so I'm going to do another one. So due to shear or due to torque, or determine our shear in the exact direction. Right, so shear in the exact direction is equal to TR or TC over J. Right, so this will be, the torque is given to be 27,600 C divide by pi over 2 C to the power 4. Okay, so if I simplify things up, this is equal to 55,200. Okay, divide by pi c cubed. So what have we found? Okay, what have we found? So we have found this. Okay, so if we draw, so this is our Z, this is our X, this is our element. Right, we can deal with 2D element. Right, why? Because we found that that is the maximum radius, right, of the mole circle is based on the in plane. Okay, so that's why we can do 2D. Right, so we found this out. This is equal to 55,200 pi c cubed, and then we have a compression. So we have a compression of minus 2,500 C minus by 72,000, right, over pi c cubed. Okay, over pi c cubed. So the next equation that I'm going to write, okay, we are going to find, okay, we're going to find, so we're going to find the center of the circle. Okay, so everything is in plane. Okay, so we're going to find the center of the circle first. Why is that? Okay, so what we're trying to do, okay, so if you look at mole circle now, this is normal stress, this is shear stress, and we drew the circle, and it happened to be our stress state. The circle looks like this, right? Our circle look like this, right? So we want to find, so this is our tau max, and we declare that this is the in plane, right? Because the other two circles are too small, okay, or smaller, not too small, are smaller. We don't need to bother, right? So this circle over here have our point over here. It has our X and it has our Z, which we just drawn. So now we're going to make sure that over here, the tau max has to be less or equal to 75 times 10 to, is it 75? Wait, 75. I'm almost done. Okay, bear with me. It has to be the question gone missing. No, 50 KSI. Okay, has to be less than or equal to 50 KSI. Okay, so in order to find this radius, right, we have to find this radius, right? We have to find this radius, right? So the center of the circle right? Center of the circle. Right, center of circle, which is our in plane, okay, will be our stress average, right, which is equal to, we can do this by stress X plus by stress Z divided by 2. Okay, and we know that stress, one of the stresses is equal to 0. We know that stress Z is equal to what? 0. There's no stresses in the Z direction. So the stress average is equal to minus 2,500 C minus by 72,000, right? Divide by 2 pi C cube. Okay. And then the next thing we have to look for is our radius of the circle. Okay, we have to find the radius of the circle, which is going to be the one that's in plane, because the in plane controls the shearing stress, is because the other two circles that are out of plane are smaller. Okay, so we know that tau max in the xz direction is equal to tau max in the zx direction. So this will be equal to square root, right? So we know the shear, right? The shear is equal to 55. We know the shear is 55,200 or 55,200 divided by pi c cube power of 3, right? And then we have to plus, okay, by the average stress, okay, that we have calculated. So minus 2500 C minus by 72,000 divided by 2 pi C cube and the whole thing squared. Okay. So now with this, I'm not going to solve it. Okay. I will put on a video on how to solve an equation like that. It's not difficult. Okay. So we know that the radius of the circle, now you have to make sure that this is equal to what? 50 times 10 to the power 3 psi. Okay, so we have one unknown, one equation, it can be solved. Once you got the C, okay, so I'll write out. Okay, so once you have the C, okay, you will find C. Okay, so the C value, I'll write down here first, is equal to 0.75057 inches. Okay, after you get this value, you need to test if, okay, the principal stress 1 and 2 is less than 100 psi or ksi. So you have to test for the what? Principal stress. Or you can test for the shearing stress. Either way, okay? So if you test for the principal stress, make sure it has to be less than what? It has to be less than 1000 psi. Then this design will work. Okay? Then this design will work. Okay? So this is what we mean by designing based on the maximum shearing stress criteria. Okay? This is based on the maximum stress criteria. With that, okay, so I will do a video. Okay, I'll do a video on this, on how to calculate. Okay, and I'll post it, and I hope y'all will watch it. Okay, so if that's the case, this is the end of the lecture. Next week, okay, Thursday and Friday are revision. Okay, now before I go on, this question over here, okay, is one of the extreme questions. Okay, it's one of the extreme questions. In your exam, okay, in your exam, I repeat again, okay, I will not ask you something so ridiculous. Okay, if I ask you something so ridiculous, I will give you my home address, and then all of you will come here and camp outside my house and probably like protest. Okay, okay, I will not do that to you. Okay, so this is the end of the lecture here. So in your final exam, you need to know how to calculate transmission shaft, and you need to know 2D and 3D mole circle. What I've taught today, at this level, you will probably use it for 3E05. Okay, so I'll save this video for you, then you can watch at your own time. Okay, but I don't want you to get worried like, wow, this is so complex. Okay, no. Okay, And that's all I have for my lecture now.